Hi, I'm Steve, Scuba Steve. Thank you for coming to my channel. I've been working with a bunch of activists who are TikTok creators, and we have started a Discord server. And one of the things I realized pretty quickly is that, we are really dependent on centrally managed servers and corporate owned infrastructure to be able to communicate. And given the fact that our Congress has decided to ban TikTok, which was a free platform that wasn't controlled by the CIA, I figured, we need to come up with strategies that allow us to work in a peer-to-peer fashion so that we have more resilience in our ability to intercommunicate with each other and continue activism as a force for good against all of the evil in the world. Okay, so that kind of labels me, it puts me in kind of a box. But at any rate, what I wanted to go through today is I have started working with a library called libp2p. And I'm using Golang as the base language. So libp2p comes in multiple languages. It comes in Rust, Python, Golang. There's a few other languages. I happen to be partial to Golang. It's a language I've really gotten comfortable with over the last couple of years. I'm a former Spring Boot Java programmer by trade. And now that I'm sort of forcibly retired, I'm looking for a new direction. So I thought I would share with you today an intro into libp2p. Now, what is libp2p? What libp2p does is it encapsulates just about every imaginable protocol you can think of for peer-to-peer networks. So if you wanted to build something like Kazaa or BitTorrent or Bitcoin or any other kind of interconnected network platform that is decentralized, libp2p provides you some foundation tools and technologies to allow you to do things like peer discovery, maintain distributed hash tables, and we'll talk about what those things are. But think of a distributed hash table as just a key value store that is spread out all across all the computers that are running the program on the internet that happen to be connected. And when one goes down, the hash table doesn't lose any data. When another one comes up, it picks up the load, so on and so forth. So you could do things, for example, like build, a content sharing and file sharing network that allows you to operate kind of like the old school BBSs, bulletin board systems. Back in the day, before the internet existed, I was running my own bulletin board service on FidoNet. I ran a couple of them. And the way those used to work was we would just have a computer that we left connected to a modem that would answer the phone after 4 rings. And if nobody answered the phone on the first 4 rings, then the computer would pick up the phone and it would start a protocol to connect to another computer. So if you were a caller and you heard this, you would just get like a beep. It was like a fax machine. But if you were another FidoNet computer, then the computers would connect and then they would download information. So then you would have like an upstream network, so you would find somebody in your FidoNet that would be the provider to you. You could be a provider to other people. And, there was this redundancy, and it was a distributed peer-to-peer network based upon telephone systems and dial-up connections where there was no central server. You had to, find a server and so on and so forth. So let's fast forward. Now we have the internet. So it's possible we don't have to use dial-up connections anymore, and people can pop on and pop off the internet, as quick as possible. So let's modernize that concept of FidoNet and bring it back with a more modern version. And so libp2p provides foundational tools that allows you to do that. So what I have on the screen here is just a basic program. So I'm just going to quickly touch on just getting started with libp2p today. So this is Golang. And what's going on here in this program is the first thing we're doing is we're creating a libp2p node here in these 2 lines. And we're saying, okay, we want to listen on all addresses on the computer network. So your computer has multiple network interfaces. So you've got the loopback interface, which is your local interface, which is usually prefixed by 127.0.0.1. I mean, that's by definition. And then there's usually at least one other interface, which is like either your Wi-Fi or your wire that's coming into the back of your computer and your Ethernet, right? Those are going to be different interfaces, and they'll have different addresses. And those addresses are locally assigned by your internal router at your house. And then that address is NATed or translated, network address translated to a public address, which is shared over the internet. So when you go to like a what's my IP, and here's an example. So I'm just gonna go ahead and do it. So First of all, I'm going to look at my local address. So uh, all right, so in this case, we have 120, 192, 168.0.234 is my local address. That's the address, and what we see here is just connections coming in. So HTTP connections, Kubernetes connections, so on and so forth, right? And then here is the here's the the loopback address, and then this is just basically something listening. So it's waiting to be connected to on an interface. So now this is the interface that is for my Wi-Fi, right? This is what my house has assigned my computer as an address. All right. So now let's just go out here and do this. So in this case, my IP today is 75.253.116.17. And that IP address changes from time to time, but this is the address that the network, the internet provider has assigned to me, has assigned to my router. So the router connects to a modem. The modem gets an address, and that's the address of your entire house network on the public internet. And then what the router does is it translates that address into specific addresses. So if you have 3 computers in your house, each has an internal IP address, um, they open up on different ports on the router, right? And then what the router does is it does that translation. So if I want to make an HTTP connection on port 443 to Google with one computer, that gets turned into a request from the router on 443, but internally there's a random IP address. There's like 65,000 possible addresses, or a random port is assigned to that connection, right? And so that's what network address translation does. So in this case, what we're telling it is we're going to listen on all networks. All right. So I'm just going to build this. And it built this little executable, which just is a command line executable. And all it does is it prints out the addresses that it's listening on, and then it quits. All right, so now I'm going to just add some code to this to enable a little bit more functionality. So what I'm doing here is I'm creating a channel, which is a golang construct. And that channel is going to wait for a signal to come in. And when it comes in, it's going to shut down the computer. So basically, what happens is, what's going to happen here is it's going to execute this. It's going to start listening here. And then it's going to get to this line right here. And it's going to wait for a signal from the operating system. All right. And until a signal comes in from the operating system, this particular set of code is just going to block. It's just going to stay stuck right here at line 31. It's not going to do anything else until an OS signal comes in, and then it gets that signal, and then that signal basically says, okay, we're going to, shut down the system, right? So while this is running, this will start a go routine. So that's going to be running on a separate thread. So that's going to be processing in the background on a separate thread, and this thread's blocked, waiting for a channel a channel signal to come in. So now let's look at what happens. So now I'm going to just build it again. And run it. So now you see it didn't stop, right? So the program didn't just immediately terminate and come back to the command line. And the reason is it's waiting for a signal. So I'm going to hit Control C, and it stops. All right, it received the signal and it shut down. So that's all for now. This is just an intro. I've got to do a little bit more work. My next goal is to set up a couple of peers and have them discover and then be able to send messages back and forth. And I will make another video later that talks about that.